Good morning, students. I am Manikant Mishra, Modern English School, New Area. We have discussed about the strong acid and the weak acid. A strong acid dissociates completely into ions. It means if you take the 1 molarity concentration of acid, suppose HCl, then when you add in water, then it gives 1 molarity of H plus ion and 1 molarity of Cl minus ion. It means strong acid completely dissociate into their constituent ions. But if you take an example of a weak acid, it partially dissociates into ions. So it is difficult to find out the strength of these acid after addition of water. So in order to solve this problem, to find out the relative strength of hydrogen ion in a weak acid, we find out the equilibrium constant, or also called ionization constant or dissociation constant. So this the value of equilibrium constant indicates whether the acid or a base is a weak acid or a strong acid or a strong base. Larger the value of equilibrium constant, often it is denoted by K, that you will study in class 11. The value of K, if the value of K is larger, then the acid or base dissociate completely into their ions. Whereas the value, if the value of equilibrium constant is less, it indicates the sum of the molecules of acid or sum of the molecules of a base dissociate partially into their ions. So we are not going to discuss much about this that you will study in class 11, but little bit there will be a need. That's why I have shared with you about this equilibrium constant. Water is a weak electrolyte. It also undergoes partial ionization. So today we will discuss about the ionic product of water. Ionic product of water. So in an ionic product of water, water dissociates into hydronium ion and hydroxyl ion. Water dissociates into hydronium ion and hydroxyl ion. You can also use hydrogen ion also and hydroxyl ion. Now apply law of equilibrium constant. So K equals to concentration of hydronium ion into concentration of hydroxyl ion. What is towards the product side, that we write in the numerator, and what is in the reactant, that we write in the denominator. And the ratio of these values gives the value of equilibrium constant. So now bring this H2O to this side. K concentration of H2O raised to the power 2. K concentration of H2O raised to power 2 equals to concentration of hydronium ion into concentration of hydroxide ion. Since the concentration of water remains constant during this process, the concentration of water do not change. It means it is a constant. So now K is a constant and H2O is also constant. So in place of these two constants, we make use of Kw. Kw here represents ionic product of water equals to concentration of hydronium ion and concentration of hydroxide ion. For your information, here again I have written it. K concentration of H2 raised to the power 2 equals to constant. So now Kw is equal to, now experimentally it has been calculated at 298 Kelvin, at 298 Kelvin. Experimentally it has been find out at 298 Kelvin the value of hydronium ion is 10 to the power minus 7 molarity and concentration of hydroxyl ion is also 10 to the power minus 7 molarity. So the ionic product of water is equal to 10 to the power minus 14 molarity square. So this information is very important while solving the numerical based on the pH. Now let us apply the use of the ionic product of water. So one of the numerical is a solution has a hydroxide ion concentration 1.0 into 10 to the power minus 4 molarity. Find the pH of the solution. Also comment on the nature. So here we have hydroxide ion concentration is given. So directly we cannot make use of the pH equals to minus log hydrogen ion concentration. That cannot make use because here it is given the hydroxide ion concentration. So that's why here we make use of ionic product of water equals to concentration of H3O plus into concentration of hydroxide ion. Now just now we have calculated, we have find out the value of ionic product of water which is equal to 10 to the power minus 14 molarity square equals to concentration of a hydronium ion. Now it is in the question is given to us that concentration of hydroxide ion is 10 to the power minus 4 molarity. So in place of hydroxide ion concentration, that value we have taken 10 to the power minus 4 molarity, that is mentioned in the question itself. So in the next step, send this 10 to the power minus 4 molarity to the left hand side. It is with the relation with the multiply, so it will divide. 1 molarity cancel. Now 10 to the power minus 4, that is in the denominator, bring it to the up to the numerator. So then minus 4, 10 to the power minus 4 becomes 10 to the power 4. So now as you know that the base is same, the power is add. But here is a minus sign, minus 14 plus 4 becomes minus 10. So 10 to the power minus 10 molarity is the concentration of a hydronium ion. Now we got the value of concentration of hydronium ion, and hydronium ion is also equal to hydrogen ion, and whose value is equal to 10 to the power minus 10 molarity. Now let us apply pH equals to minus log hydrogen ion concentration pH equals to minus log. Now we have hydrogen ion concentration value. We have the value of hydrogen ion concentration 10 to the power minus 10 molarity. This value you take substitute here, then pH equals to minus, you take as first keep it out, then log m to the power n. In a previous video we have already discussed log m to the power n equals to n log m. Log m to the power n is equal to n log m. So now minus minus plus 10 log 10. 10 log 10. Log 10 value is 1. So now 10 into 1, 10. pH is equal to 10. Now as you know that more than 7 in a pH scale, if the pH of any solution value is more than 7, then obviously the nature of that solution will be basic. So one thing here, if directly it's not given to us the concentration of hydrogen ion, then we can make use of the ionic product of water. With that, we have to find out the concentration of hydronium ion or concentration of hydrogen ion. Then we can make use of the pH formula. Then we have calculated and also we have asked the comment the solution is a basic in nature. Thank you. Have a nice day.